This video is for Chapter 11, Section 3, and we're going to be looking at the surface area of pyramids and cones. Previously, we've been studying polyhedrons, prisms, and cylinders. Now we're going to the next family of shapes, pyramids and cones. Let's take a look at the pyramid. So, pyramids have one base, and then all the faces from the base come together at a point. I've chosen to use a hexagon-based pyramid because it's uncommon. You've all seen pyramids with square bases. So this is a hexagon-based pyramid. There are four major parts that we have to be able to identify. A base edge, and the base edge is the number of sides of the base, how many there are. There is an altitude, which is the height. This is important. This altitude comes straight down from the tip of the pyramid to the center of the base. If this pyramid is sticking straight up, it will come down to the center of the base. That we will refer to as the height. There are the lateral faces, which are the triangles that come together at the point. All lateral faces are triangles in this case, and the slant height is actually the height of the triangle. Now we're going to see that in a different way right here. So see, I have unfolded this this pyramid into a net. Here's the hexagon base, and here are the base edges. Here are the lateral faces, the triangles. Notice the one thing we cannot see in a net is the height. It's gone. We have unfolded the shape. So the slant height is now, you can see, it is the height of the triangle. So our goal here is to try to figure out how do we find the surface area of a pyramid. So, based on the fact that a pyramid is a polyhedron with a polygon base, we know we're going to add the base at the end. The other faces are triangles. So we need to find the area of the triangles, and they're all exactly the same. So if we could just find the area of one triangle and multiply it by the number of triangles, we would have the lateral area. Okay? And then from there, we could then add the base to it. So let's put this together using a square-based pyramid. The lateral area is the sum of the lateral faces, which are the triangles. The triangles here, their base is the side length of the square, which is the base of the pyramid. And the slant height is the height of the triangle. So we could say that the lateral area is the area of the triangle times the number of triangles. Well, the number of triangles just happens to be the number of sides. So let's replace that. And according to this picture, the area of the triangle is 1/2 base times height. 1/2 side times slant height. Now within this equation, I noticed that if you multiply the side length by the number of sides, let's use real numbers for a second. If the side length was 10, 10 times 4 would be 40. That's the perimeter of the square. So side times number of sides can be shortened into perimeter of the base. Side times number of sides is perimeter of the base. We can now shorten this equation to 1/2 perimeter of base times slant height. This is important. Prisms was perimeter of base times height. Now we're looking at 1/2 perimeter of base times slant height. This is our lateral area formula that we need to have written down and work to memorize for our relationships. After that, when we say surface area, we only have one thing left to add. One base, not two bases. So our surface area is our lateral area, 1/2 perimeter of base times slant height, plus one base. Whatever that base is, rectangle, square, circle, triangle, hexagon, we're going to have to find separate formulas to find the area of the base. Okay, now let's look at the lateral area and surface area of a cone. Now a cone is just a pyramid with a circle base. So it should have the same equations. we should be able to say the lateral area is still 1/2 perimeter base times slant height. But we know that perimeter of a circle has a special word, circumference. So I'm going to say perimeter of base is the same thing as circumference, which is 2 pi r. So I'm going to substitute 2 pi r for perimeter of base, right here. 1/2 circumference times slant height. 1/2 2 pi r times slant height. The 1/2 and the 2 will reduce each other out, and we will be left with pi RL. So this part here in the yellow is the actual formula you will write down. The lateral area of a cone simplifies to pi times radius times slant height, pi RL. Now, after that, the surface area just means you have to add one circular base, and that's one of the easiest things for us because the area of a circle is just pi r squared. So the lateral area plus one base is the same as saying the lateral area plus pi r squared. Pi RL plus pi r squared. Pi RL plus pi r squared. That is our surface area formula. Now we got to look at a couple of examples. We got to look at some things in relationships. For example, check this pyramid out. It's one of the pyramids in Egypt. 756-foot base. And the pyramid is 481 feet high. That's the height. That's not the slant height. And we need to find the slant height, the lateral area, and the surface area for this pyramid. Because if I want that lateral area, and I have to say LA equals 1/2 perimeter of base times slant height, I can figure out the perimeter of the base. It has a 756-foot base, so I take 756, multiply that by, let's get the right number in there, 756 times 4, and I've got 3,024. I know my perimeter of the base. What I don't have right now is a slant height. But what I do see is a right triangle. Okay. Level 2 in this class was all about how we can utilize right triangles to help us. So now we need to use that right triangle, and we need to use the Pythagorean theorem to find L. So we are going to have 378 squared plus 481 squared is equal to the slant height squared. This is going to be a really important relationship. So I've got some big numbers. 378, let's see, well, let's put in squared, plus 481 squared. That's going to be some big numbers here. I've got 374,245 equals L squared. Let's take the square root of that answer there. And we have a slant height of 611.7. So we're going to go ahead and say that it's approximately 612 for a slant height. Now, once we have the slant height, we can find the lateral area. And that lateral area is 1/2 the perimeter of the base times the slant height, 612. So, again, these are not numbers that I'd be doing in my head. I've got 3,024 times the 612, and then I'm going to divide that by 2, and I've got a lateral area of a gigantic number, 925,344 square feet. Just to put in perspective, that's how much stone is on the outside of the Great Pyramids in Egypt. 925,000 square feet of stone. Now, if they created a floor for this pyramid, we're going to need the surface area, which takes a base. Well, our base is a square, so 756 squared. If we take 756 squared, we just added another 571,000 square feet. 536 square feet of material. So we're going to have to put those together. I'm not even going to write both of those numbers down, but I have 925,344 plus this 536. And we've got some monster numbers of 1,400,000 496,880 square feet of concrete or rock or stone or whatever it is they use to build that pyramid. That's pretty intense. Now, I said there was going to be an important relationship that came to this, so hopefully you've taken down this example, because I'm going to go right back to this Pythagorean theorem right here. This Pythagorean theorem, a lot of students miss that these are specific parts that you already know. The slant height, 481 was the real height, and what is this value here? In squares, we rarely ever use this, but if we saw it in a hexagon, we might realize from the center to the center of a side, that's the apothem. And so this formula right here is apothem squared plus height squared equals slant height squared. Now, this is a very, very important relationship that we should be writing down for pyramids. And for cones, it's slightly different because we're about to look at some examples. For cones, here's our cone with a little diameter in there. The right triangle is formed with the height, the radius, and the slant height. So r squared plus height squared equals slant height squared. I'm going to leave those up for a second while I get ready to do our final two examples, which is, how would we find the LA and surface area of these two figures shown? The cone is going to be the easier figure. This is one of the toughest problems of the entire unit, how to work with hexagons. That's why this video is a little longer. So, we're going to come back to both of these. I'm going to leave this one up for now because here I am working with a hexagon-based pyramid. And to find the perimeter of the base, so I want lateral area equals 1/2 perimeter of base times slant height. I know what the perimeter of the base is. That's not hard. One side is 10 and there are 6 sides. 6 times 10 equals 60. Half of 60 is 30. If I just knew what that L was, well, that's where I got to see this weird, awkward right triangle right here. And I'm going to do a lot of this in class when I get back. But right triangle, height is 5. Here's the apothem. What is the apothem of a hexagon with a side length of 10? Some of us have this memorized now, and we remember that that apothem is 5 radical 3. We cut the side in half and add on a rad 3. So I now have 5 radical 3 squared plus a height of actually 5 squared is equal to L squared. 5 radical 3 squared, well, 5 squared is 25 times 3. That's 75 plus 25 is 100 equals L squared. Thank goodness it worked out to be a nice number. Our slant height is 10. Our lateral area is now 1/2 60 times 10. Well, 60 times 10 is 600. But that in half, we've got 300 centimeters squared. So there's our LA. A lot of stuff to keep track of on the board here. Our surface area is now that LA 300 plus the area of that hexagon. Now this was on the last test. How do you find the area of the hexagon? So let's put together 300 plus 1/2 apothem times the side 10 times the number of sides. Okay, so we have 10 times 6 is 60. 60 times 5 is 300. Half of 300 is 150. So 300 plus 150 rad 3. I'm going to leave this here as the surface area of this hexagon as the exact answer, because I don't know what the square root of 3 is. But all of us can go to our calculator, bring this down to a decimal. That is for us to do in class. So there was a lot there. Pythagorean theorem to find L, slant height. Using the formula to find lateral area. And then using the formula from level 3 of how to find the regular hexagon's area. That is the first example. Okay? You can pause it to look at any of this material. Second example is the cone. So now we go to the cone. Now the cone's formula is LA equals pi RL. Pretty short formula. I look at this picture here. The diameter is 6. My radius must be 3. So what's L? Well, in this picture, it's already given to us. The L is 8. I didn't have to use this formula. R squared plus H squared equals L squared. It's not needed this time. They gave me L as being 8. So they gave us all the parts. LA equals pi times 3 times 8. 24 pi. My surface area is just that 24 pi plus a circle, which is just pi r squared. Well, we already know the radius is 3, so we have 24 pi plus pi times 3 squared. So 24 pi plus 9 pi. 33 pi. Again, this is the exact answer where I will leave it for today. You can use your calculator to create the decimal version of this answer. That's it for Chapter 11, Section 3, the surface area of pyramids and of cones.